In this example, we are being given a velocity equation for a particle with this equation right here, but they're asking us about the acceleration of the particle at a specific time. What we have to do is we've got to know this classic little physics relationship that they want us to know like the back of our hand when we go in to take this test. If my original graph is the position graph, then the derivative of position is going to equal my velocity equation. And then the second derivative of position, or important to us right now, the first derivative of velocity is equal to acceleration. And it's that little connection that we want to make for this problem. The first derivative of velocity is equal to acceleration, and we were given that velocity equation to start with. So what we're really being asked on this problem, what they want from us is they want to know what is a of 2, what's the acceleration at 2. More importantly for us here though, we want to recognize that that's really asking us what's the derivative of our velocity equation at 2. At this point, you might be freaking out a little bit because you're saying to yourself, oh man, that looks like a nasty derivative to have to work myself through. The great news here, though, is we don't actually have to go through all this work by hand because this is in the calculator required section. So what we're going to do actually is we're going to let the calculator do all the heavy lifting for us. We're going to go ahead and we'll graph that starting velocity equation. So you're going to take the velocity equation, pop that into y1 on your calculator. Instead of a t, you're going to want to put an x in there whenever you're graphing. So that would be step 1. Step 2, go ahead and just hit that graph button. And then step 3 of the process, we're going to hit second calc. We'll choose the calc menu, and inside that calc menu, we're going to choose the number 6 option, dy dx. From there, we're going to then plug in the value we care about. We're looking for the derivative of velocity at that value at x equals 2. So we'll type in 2, we'll hit enter, and at the bottom of the screen, it's going to say dy dx equals, and whatever that is, that's going to be the answer we're looking for, because that would be our acceleration at 2. So doing this in the calculator, we open up our calculator, go to that y equals in the top left corner there, type in that original equation exactly how it looks. And again, when we go to graph, we always put in x's instead of whatever the variable is they're talking about. So toss that into y1, we hit graph, and now from there we're going to go calculate the derivative at 2. So we hit second, the button in the top left, then you're going to choose the calc menu, which is the button above trace at the very top of the calculator, and inside that menu you're going to look at the number 6 option here, dy dx. You hit enter on that, it puts you back on the graph, and it doesn't prompt you to type in the x value that you care about. You need to know that that's just the way the process works. It's looking for an x input. We want to know what's happening at 2, so I type in 2, I hit enter, and you'll notice right underneath the graph there it says dy dx equals 0.280. That is our answer. So we know that our acceleration at x equals 2 is going to be 0.280, excuse me. So our answer would be this value right here. Again, the calculator is a good friend. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.